Okay, now this type of equation is a little bit different. Now let's just think for a minute, what does this look like on the left hand side? Now as we study it, we notice that we've got 1, we've got a power here of 1, then 2, then 3. Okay, this one here could be considered as z to the power of 0. Okay, so now we've just done sequences and series, so hopefully you can recognize this is a geometric series. So what that means is we can look at this as a sum, okay, to 4 terms. Alright, so that's an important way to solve this particular type. Okay, if you can recognize that it's a series, then we use that knowledge in solving it. So, given our left-hand side is a geometric series, with our first term equaling 1 and our common ratio equaling z over 1, z squared over z, which becomes z over 1. Okay, so our common ratio, z over 1, is z, and the number of terms equals 4. Now that's helping us because we remember that the sum to n terms of a geometric series is given by a outside of 1 minus r to the n over 1 minus r. So that expression there can be used in replace of the left-hand side of our equation. Okay, so that's our left-hand side, which is equal to that sum. So that's going to be equal to 1 times 1 minus r to the n, so that's z to the power of 4 over 1 minus z. Now let's go that little step further. Okay, this being our left hand side is going to be equal to 0. Now we can simplify this, multiplying both sides by 1 minus z. We have 1 minus z to the power of 4 equals 0, because 0 times 1 minus z will be 0, obviously. And then we have negative z to the power of 4 equals negative 1, or z to the power of 4 equals 1. Now, in a previous example, we worked out what z to the power of 4 is. Okay, so I didn't go through that again. Z to the power of 4 equals 1 gives us the solutions. Z equals plus or minus 1 and plus or minus I. Now, that's 4 solutions. But notice up here, our polynomial is a degree of 3, so there should only be 3 solutions. Okay? Why are there 4 solutions? Well, because we have power of 4 here. So what's with the contradiction that we've got? Well, if we have a look at our sum to n terms of a geometric series, on your information sheet there should be a restriction shown, and that is that r cannot be equal to 1, because 1 minus 1 would give you 0, and then we'd have division by 0. So that's a really important part to remember in sequences of series, but also in this, what we're doing. Okay, so in this case, that means that z cannot be equal to 1. Okay, so that rules out one of our solutions. Okay, z's not equal to 1, therefore our solution is z equals negative 1 and plus or minus I. Okay, let's look at this next example. Solving 1 plus z to the power of 4 equals z to the power of 4. So in solving this, we're just going to collect everything over to the one side. And so if we do that, we're not going to do that by subtracting z to the power of 4, but by dividing. Okay, if we divide both sides by z to the power of 4, we'll end up with 1 plus z to the power of 4 over z to the power of 4 equals 1. Now, we've got powers of 4 above, powers of 4 below, so we could write this as a single fraction all to the power of 4, and that equals 1. Now, just imagine that this was, say, w to the power of 4 equals 1. From our previous example, we found that w would equal plus or minus 1 and plus or minus I. So, in this case, just solving for this expression here, we can make that so that 1 plus z over z equals plus or minus 1 or plus or minus I. So we've got 4 solutions here for this expression. Okay, so let's go then to the next step. We need to consider this expression equaling each of these 4 values. So 1 plus z over z equaling 1. Z, multiplying z both sides by z, we have 1 plus z equals z. And then if we subtract 1 from both sides, we've got z equals z minus 1. So in this case, there's no solution. It doesn't make sense. Okay, if we could subtract z from both sides, it will have 1 equals 0, which makes no sense. So in this case, that results in no solution. Okay, so that's the first one. The next one, 1 plus z over z equals negative 1. So that 1 plus z equals negative z. Adding z to both sides and subtracting our 1, we'll have 2z equals negative 1. And then dividing by 2, we've got z equals negative 1/2. So that's a solution that's valid. Okay, next one, 1 plus z over z equals I. So we've got 1 plus z equals iz. Subtract that, we'll have z minus iz equals, and subtract our 1, so we've got the 1 over the other side, negative 1. Take out z as a common factor, so we've got z outside of 1 minus I equals negative 1, and then dividing by 1 minus I, we've got negative 1 over 1 minus I. Now we don't like to leave it in that form. Okay, we want to have a real denominator. So multiplying by its conjugate, 1 plus I over 1 plus I, we end up with negative 1 minus I over 1 plus 1, which is 2. Negative 1/2 minus 1/2 I, or I over 2. So that's our third, the next one. So then we've just got one more to go through, and that is 1 plus z over z equals negative I. And solving for that one, we've got negative iz. Bring that over here, we have z plus iz equals negative 1. Factorise, So z outside of 1 plus I equals negative 1, and then z equals negative 1 over 1 plus I. Realise the denominator, so we've got 1 multiplied by 1 minus I over 1 minus I. So we end up with negative 1 plus I over 2. We could leave it like that, or we could put it like this. Okay, so we find that we have three solutions. Okay, so the solutions are negative a half, negative 1 half minus a half I, and negative a half plus a half